let's begin with the webinar today. So here we are going to discuss about artificial intelligence today. The topic for the day webinar is artificial intelligence and machine learning by TechTrunk Ventures Pvt Ltd. We'll be discussing about artificial intelligence and machine learning. The topic will goes on to some introduction of artificial intelligence and some idea about machine learning, and thereafter a basic concept of machine learning, that is linear regression. And we'll be also looking at the content that we have for the training on artificial intelligence and machine learning by TechTrunk Ventures Pvt Ltd. So we have a 7-day training module on artificial intelligence and machine learning. So we'll be also analyzing the content and what are the sort of things and practicals that we're going to cover up in this particular training. So let's begin with that. The very first question that you might be having of you, the idea of what exactly is artificial intelligence and what do you mean by that? So artificial intelligence can be easily defined as it's the capability of a machine to imitate the intelligent human behavior. Am I audible to all? Yeah.
Hello.
Yes, I'm audible to you properly.
So one of my students, she wants to join from the phone. Actually, I run the training institute here in US, and one of my students, she's interested in this AI course. She wants to join from the phone. So what number should I give her?
With the link itself, you might be getting one number. So that's the number you can use to connect from the phone. With the link which we have been forwarded with mail. In mail, you might be having a number. While you connect, you will be getting a number to join from the phone. Or otherwise, you can also download the app for GoToWebinar from Google Play Store if you're using Android phone. And by just giving the ID, you can join from that as well. I hope that works. Okay, so any other question?
This is GoToMeeting or webinar?
GoToWebinar. GoToWebinar it is.
GoToMeeting. Okay. Okay, I will tell her.
Yeah, sure.
So, okay, she will join now. Okay,
sure.
Bye.
Okay. We're discussing about this part, what exactly is artificial intelligence and what do you mean by that? Artificial intelligence can be called as the machine imitating a human, where human is doing any work which requires intelligence. For example, if you're riding a car or you're riding a bike, you take decisions while on the street. Whether a bike or vehicle is coming in from front, back, or left or right, every time you take decisions according to the constraints over there. And whenever we being humans take any intelligent decisions and we want machines to imitate those decisions, that sort of technique is called artificial intelligence. So anything that requires a machine to perform an intelligent task can be called as the technique of artificial intelligence. Another definition of AI could be, it's a way of making a computer or a computer controlled robot or a software think intelligently in similar manner how we being humans think. For example, as I said, if it is a task of making a tea, so how much sugar has to be poured and how much milk has to be poured for getting a particular test. So that's again a manner or a work which requires intelligence. And if a computer is performing that sort of task, it requires some intelligence. Or how to recognize a particular characters or how to recognize the voice of a person. So those are all intelligent based tasks in which we have some knowledge, experience, and we perform that task. We being humans perform those sort of tasks easily. And when you want our computers, the algorithms, the programs to perform similar tasks, we need to design certain algorithms and programs which can do this. And that sort of work where we design similar programs is called artificial intelligence, providing this technique to computers. So throughout the session, we'll be discussing more about AI and one part of AI, that is machine learning, and getting thorough with machine learning, and one technique of it, that's linear regression. So as soon as we move on, the idea of AI and machine learning will get more clear to you, and you can ask any questions if you have by raising your hand or otherwise by asking any question to the chat box. Let's talk about applications of AI. So if you talk about applications of AI, so if you the last 5 years AI was a bit limited. It was only into the books of colleges. It was only into some research labs, only limited to that part. But from last 3 to 4 years, we in the technological world have some processors, some computational power which can process all these algorithms very efficiently, and we have plenty of data which can be used to perform some AI based techniques. And these two reasons has made AI come into the corporate world, come into the industrial world, where each and every company whosoever might be using any kind of product, providing any kind of services, it could be management, finance, biology, any kind of company it is, they all started implementing AI-based algorithm in their products and services. One of the, you can say, traditional use of AI was limited up to the advertisement world. Some companies like InMobi, Google used to use AI to track the customers, to track the users, what they are looking for, what they are searching for, and advertise them the advertisement of a particular product. So that was one of the use of AI that was limited till date. And now it has come out of it, and we have a lot of applications starting from optical character recognition, recognizing the handwriting, recognizing the speech of a person, face recognition, some creativity stuff, computer vision, virtual reality, image processing, diagnosis, game theory, strategic planning. So these are a couple of only plenty of applications that I have mentioned over here. There are even numerous applications other than this. Even people use AI for finance, share market predictions, and housing prices prediction. There are unbelievable applications of AI as well that you will find everywhere. One of the applications that we are even currently working on is something like developing some HR-based applications in which the algorithm or the computer will try to analyze the people who are applying for a particular job, and for every job we'll be having an algorithm and some dictionary which will recognize a particular CV and whether that person is having those skills, those experience which are relevant to particular job criteria or not. And according to the questions he asked to an HR person, the algorithm will also analyze those questions. It will process those raw language and understand that how eligible a particular candidate is for a particular job position. So in management, ERPs, everywhere, AI is going to find a lot of ways, a lot of applications, a lot of possibilities. And there can be numerous applications tracking data of users, tracking data of their medical sciences, one of the very promising domain in which AI is going to penetrate a lot more. So there are a lot of applications of AI which we'll be discussing throughout this course, and throughout this video we'll be discussing a couple of applications. And AI is broad. AI is not limited to machine learning. Machine learning is one of the part of AI. There are a lot of domains. There are a lot of you can say techniques of designing AI-based algorithm. There are a lot of types of AI agents. The types of agents could be a simple reflex agent which can simply take an input from environment, take a decision based on that, based on the knowledge he is having, and take a decision. There could be some utility-based agent or goal-based agent, the agent which reaches to the goal and takes care of the steps it has to take for reaching to the goal after getting the data from environment, after using its own knowledge. There could be some agents like utility-based agent. For example, if you're driving a car, the agent will also take care that it makes you comfortable while reaching to the optimal position, optimal solution. So there can be a variety of agents. There can be a variety of applications wherein we can implement artificial intelligence, and some of them are mentioned over here. These days, the buzz of AI is into data analytics and the predictive analytics, the IoT data analytics, and these are all applications wherein these days you will find most of the use of artificial intelligence into the general world in which we are living up. And most of those are backed by one of the technique of AI, that is machine learning. There are various techniques of AI including fuzzy logic analysis, genetic algorithm, particle swarm optimization, and some of the techniques comes under the category of machine learning. We'll look through what exactly is machine learning. So let's talk about the another buzzword frequently taken with artificial intelligence, that is machine learning. What exactly we mean by machine learning is, first we'll have to understand the word learning part. What exactly we mean by learning? Learning is a process in which we go through a couple of experiences and we update our knowledge, which helps us in taking better decisions next time we go through the similar process. For example, if you analyze how do we learn to recognize the characters A, B, C, D, 1, 2, 3, 4, 5, 6, 7, 8 like that, once we learn from books, the very first time that you might have seen A, B, C, D, small or capital case, you might have seen it through books. And as soon as you see those characters, a number of times you write those characters, a number of times you try to recognize those characters, number of times in book throughout the years in junior KG, senior KG, in first class, you get used to it. The knowledge in your brains, the neurons in your brain updates those knowledge that this is how A looks like, this is how B looks like. With every experience, every time you perform a task of reading those characters A, B, C, D, it helps you to gain a more experience, which helps you to again increase your performance while again recognizing those characters. In a simple way, let's say that you're riding a bike for the very first time, and if you make a mistake, the next time you try to ride a bike, you try to avoid that mistake. It means as soon as you're riding a bike for the very first time, it helps you to gain an experience. And that experience helps you to improve your performance next time you try to ride a bike. That's what we call learning process. Every time we do a particular task, the task helps us to gain, if the task helps us to gain some experience, and if that experience is helping us to increase or improve our performance next time we are performing the similar task, we can call that this process is a learning process. I hope I'm clear with what exactly is learning. It seems somebody's having a question. So let me, it seems it's not possible. Am I audible, Aisha ma'am? Do you have any questions, seems? Okay, seems no questions. Let's see when next time she connects up. Then talking about machine learning, we have seen about learning part. What exactly is machine learning? So first we have seen that according to Herbert Alexander Simon, one of the father of machine learning call, so he has got some kind of Turing Award and Nobel Prize in economics as well. According to him, learning is a process by which a system improves the performance from experiences. That's what you have discussed so far. And what exactly is machine learning? When a machine is doing similar task, when a machine is trying to improve its performance by doing a task and using the experience gained from that task, the machine is said to be learning, and the process is called machine learning. It's like if let's say that if writing a C code, if you make a mistake of semicolon and a number of times you run that program, it will show you the same error. Or let's say you made a mistake of writing 10 plus 2 and you got an answer like 12. You wanted to get something 9 plus 2, or let's say something like that, something different than that. But every time you run that program, as the program is written in very explicit format. So the answer that you'll get in from that sort of program will be always same. It will not change because the machines never learn it or generally do the same mistake as it does for the very first time. When you make computers to automatically recognize their error and improve their performance through the experience they are gaining up, we can call that machines are learning. For example, how do we learn is, for example, if you're riding a bike for the very first time and you made an accident, right? So next time you try to ride a bike, you try to avoid that accident. It means you try to minimize the error between the correct way of riding bike and incorrect way of riding bike where you made an accident. So we humans learn by trying to minimize the error that we generally get. And that's what we call machine learning. When machines does similar stuff, when machines tries to improve the performance by minimizing the error between the subsequent task. Or you can say when machines does improve performance by the virtue of experience the gain by performing a certain task. So that's what you call machine learning. And one of the relevant example we'll see in coming slides wherein we'll be talking about linear regression. Now this is what we have seen, the meaning of machine learning. Now the question could be, what is the objective of a learning algorithm or machine learning algorithm? Why do we do that? Why do we need machine learning algorithm, or why do we perform machine learning? So the objective for a machine learning algorithm, or why we are writing a machine learning code or an algorithm, should be getting better at a task through the practice. Whatever task we are practicing up, getting better insights of that, or doing it better. For example, let us say that there's an algorithm which is recognizing a voice, and for the very first time it does some mistake, and you try to change it, and let's say till 3 days it do not repeats that mistake. But after 4 days, if it repeats the mistake or if it does the new mistake, you're not going to program it again every time when it does a mistake. So the algorithm for recognizing a voice should be that flexible, should be that capable of minimizing its error on its own. So getting better at a task through practice. When it does a lot of tasks, it should try to improve its performance. When you want to do that, you can employ a machine learning algorithm with the particular task. The second objective could be the act of remembering the data, the experiences. For example, when we ride a bike, we remember that how we did perform the last time we ride a bike. Machines don't do that. When we want machines to do that, we can employ a machine learning algorithm with that. Similarity in new inputs, and trying to find out what is the overview of data. For example, let's say that a temperature data, or let's say that 1,000 people are accessing facebook.com, and what sort of general thing they are doing throughout the day. For example, let's say that today is Sunday, so most of people who might access Facebook today might post something about where they are and where they went to go for some tourist places, or they went to for a restaurant or something like that, of party. They might do some post related to party fun. To generalize that data, what people are doing, similarity, find out the similarity in the data, what people are doing, a machine learning algorithm could be employed over there. The learning and flexibility, adapting the environment, and based on that, putting some insights or providing some output to the users. These are all various sort of tasks where you can employ machine learning algorithms. So overview of machine learning algorithm is when a computer learns by improving with the performance, it is gaining with some task T. So you can say when a computer is improving over task T with respect to the performance measure P based on the experience C, the computer is said to be learning, and that algorithm which is helping a computer to do all the stuff to improve its performance with an experience E with gain from a particular task T can be called as a machine learning algorithm. I hope the basic idea of machine learning would have been clear by now. Next, talking about machine learning around us, like which are the things that we see around us as machine learning. So you might have seen Cortana or Siri. So these are all two machine learning based agents. Voice recognition system, handwriting recognition system, spam filtering on your Gmail account, where an algorithm tries to filter whether a particular mail is spam or not spam. That's again a machine learning algorithm. Player ranking in online games, vehicle stability systems, computer vision, data mining, web click data, medical records. Talking about some general applications, I use Quora a lot of times, and if you go on Quora, if you try to analyze that which of the tasks on Quora and backend are supported by machine learning algorithms. So some of the tasks could be answer ranking. Whatever answer we do on Quora ranking those answers, it uses a machine learning algorithm. Feed ranking, topic recommendation, it recommends you some topics so that you can get engaged to those topics. User recommendation, email digesting, ask to answer, to whom, particular question you can ask to which users, according to whatever answers they might have given in past to the similar questions. So analyzing all those data, for example, let's say that I have given some answers on correlated to artificial intelligence now. For an algorithm to analyze me, that what sort of intelligence or what sort of specialization I'm having, based on that, the algorithm can recommend my name to some of the users who are looking for some answers to the artificial intelligence-based question. That task is done by a machine learning algorithm in backend working on Quora. Detecting the duplicate questions, detecting the related questions, or spam, trending questions, trending answers. All those stuff on Quora is done by a machine learning algorithm. So you see, on a single forum, a single platform, these are number of tasks which are backed by machine learning algorithms. Okay, so let's go on with this. So we have so far discussed, if I just recall the slides that you have seen so far. So some of them would be like what we did so far is we went after what exactly is artificial intelligence. So we have seen that it's capability of machine to imitate human behavior or human intelligence, and it can be a way of like machine to think or to work intelligently as humans do. Some applications we have seen like optical character recognition, recognizing our handwriting. For example, all of us throughout the world write everything differently, right? When you want to recognize those, and when you want to make a computer recognize those characters, you need an AI-based algorithm backing up. The very simple example is, let's say, fuzzy logic-based washing machine, where the washing machine analyzes the amount of dirt in your cloth and the amount of cloth that you're putting it into, and based on that, using fuzzy logic algorithm, it tries to understand that how much rotations or how much cycles of washing it has to do with a particular set of clothes. That's also an artificial intelligence-based algorithm. And there are a lot of other algorithms as well, like other applications as well. including computer vision, virtual reality, image processing that we have seen so far. Talking about what exactly is machine learning. So it's a process of learning where we try to improve our performance by just gaining some experience by doing some task T. And that's what learning is equal to the improving with experience at some task T. And when computer does that, when a machine does that part, the technique is called machine learning. Some of the applications we have seen includes voice recognition, handwriting recognition, spam filtering, player ranking. Even on Facebook, like Facebook recommends that these are the friends you can go on with. Twitter recommends to whom to follow, or some of the tweets which are much more related to you or much more interested to you, or how the Facebook does marketing or marketing the products of other companies, how Google does marketing, showing you advertisement on different websites. All those stuffs and paths, all those works are backed by some machine learning algorithms. Okay, and Mr. Anand wants to speak to me, so I'm going to unmute him. Yes, Mr. Anand, I can hear you.
Hey, I just wanted to check. So, do we need to have any technical background to get this training done, or like people from non-IT background can also start from scratch and
Yes.
Learn it?
No, we just you need to have some idea of mathematics. That's what important part is. And talking about programming part, we teach programming from very scratch, but mathematics is important.
On mathematics, what level of expertise you are saying?
Mathematics simply understanding the equations, mathematical equations like linear algebra, the mathematical algebra like x square plus like quadratic equation, and how summation part is done. Okay, some statistics idea. If you have that idea, that is much more better for you, because AI is backed by mathematics.
All right. Now I have one more question. When you said about statistics, right? So I read that there are too much of statistics involved when we are programming or doing any kind of programming for AI. So I mean, it's too much of statistics, or like I mean, do we need to be very good at statistics and algorithms and everything?
Yeah, it completely depends on your application part. You see, if you're just designing some basic ideas or basic projects, if you're not going to dive deep into that, then there are a lot of functions which does all the statistical part for you, all the mathematical computation for you. So you just need to have idea of it. Okay, and you won't be needing to use them and write equations in your program very frequently. So if you want to do so, that is also possible. If you want to do research and design your own functions, design your own algorithms, then you will have to do it. If you want to use some existing algorithms which all the mathematicians or researchers have designed already, so you'll get ready-made functions for them. You just need to understand how it works and when to use it.
Okay, got it.
All right. Okay. Yeah. Others, if you have any questions, you can just raise your hand, and I'm raising down your hand, Mr. Anand. Okay, so let's go on with this part. Next, talking about the supervised learning, like machine learning part. There are the two basic types of machine learning. One of them is supervised, another is unsupervised. So when you talk about supervised learning is a type of learning when we feed some data to machine. For example, let's say that I'm running bike, and if my father is there to teach me what are the good ways of riding bike, what are the bad ways, what are the good steps, what are the bad steps. So he's teaching me, I'm having a mentor with me, I'll learn very quickly, and my output will be very accurate than the condition with nobody's there to teach me. So there are a lot of places where we can feed some data, train our algorithm, teach our algorithm to make it perform some tasks like this, like that, like this, like that. For example, let us say that you have email spam filtering. So you can teach your algorithm that this type of emails are spam, this type of emails are not spam. So that sort of learning is called supervised learning, where you have some data which is labeled, where you have some data which is labeled that this is that, this is that. For example, when you have thousands of mails, and each of thousands of mails are labeled that this is spam, this is not spam, this is spam, this is not spam. That experience, okay, because how do we get labeling? How do we get how do we get to know that a particular mail is spam or not spam? We understand that. We read those mail and we label those mail that this is spam, this is not spam. We can feed the data of those 1,000 mails to an algorithm. Algorithm can understand that this type of mail are spam, this type of mail are not spam. And based on that, then algorithm becomes able to predict whether a particular new email is going to be spam or not spam. So that sort of learning is called supervised learning, where we need to feed a labeled set of data to the algorithm so the algorithm can learn from that data, and then algorithm becomes able to give you answers. It could be, let's say that if there's algorithm which is just recognizing your face, so we'll train the algorithm by different faces of yours, like different images with different angles of your faces. It could be some front face, right hand side face, left hand side face, the front, top, bottom, different set of faces. We can train those images to the algorithm, and algorithm will be able to recognize your face from any angle. So when we train the algorithm with some label data, some right answers, that this is the right answer for this sort of input, then the algorithm becomes able to answer you for any new data, any new questions. So that sort of learning is called supervised learning. Another is unsupervised learning. What we mean by unsupervised learning is when we have no idea of what could be the possible answer. Let us say in email filtering, the type of output could be either spam or non-spam. So it's very easy to label the data that this mail is spam, this mail is not spam, and make an algorithm understand that. So when we have some unlabeled data, or let's say unconstrained data, then we talk about unsupervised learning. Some of the example could be every day you go to Google and search about some news, and Google News gathers the news headlines from different websites. So the Google News algorithm cannot predict that what will be the news tomorrow and gather the data based on that news tomorrow or the news headline. It has to just find out the similarity between the news headlines on different websites, whether it is BBC, whether it is India Today, or different other website. It tries to find out the similarity between the headlines and gathers all the similar headlines together to show you that this is the news today. That's an example of unsupervised learning technique, where we do not feed, and in some cases we cannot feed some label data to the algorithm. So classification of email is an example of supervised learning, wherein we classify the email as whether the email is spam or not spam, or an algorithm is classifying the email as spam or not spam. So this is an example of supervised learning classification example. There can be some other classification example that whether if we have some patient data, okay, so whether a patient is having malignant tumor or benign tumor. Okay, it is benign or cancerous, like malignant tumor is kind of cancerous tumor. So whether a particular patient is having benign or malignant tumor, so recognizing that can be again an example of classification. Whether a particular lead is given by a website or a salesman, whether that lead is profitable or not profitable, if a computer algorithm is learning and trying to predict that whether a particular lead is profitable or not, then that is an example of classification. And again, it's a supervised learning technique. Or who will win the presidential elections in coming up? So we can feed some data who won the presidential elections according to type of advertisement, or let's say type of campaigning they did when they became president of United States, or when somebody became the prime minister of India. So what kind of campaigning they did, what kind of work they did, what kind of image he was having. So an algorithm based on learning that sort of data can predict who can become the president or who can become the prime minister in next coming elections. So all these classification examples are supervised because we feed them labeled data. We feed them some known or right answers. Talk about another kind of examples, that is regression examples. There can be some regression problems like how many units of product will be sold next month, or how much marks a student is going to get based on the number of hours he's studying, or what the market price of a particular house. Okay, based on the environment, based on the people living there, based on the expense the people are making in a particular society, an algorithm can predict what will be the market price of a particular house. Or how long before this engine needs repair, after how much time this engine needs repairing. So based on the users, based on the time, based on the speed that you do, or based on the type of users or type of driving that you do with that engine, the algorithm can predict. Now, what is the difference between this regression examples and this classification example is, in classification example, the answer is fixed. For example, in the first case or in the previous case, whether the email is going to be spam or not spam, only two answers. Whether the tumor is going to be benign or cancerous, only two answers. The lead is profitable or not profitable, only fixed set of answers. Who will win the presidential election? So there are fixed candidates who are fighting or who are just campaigning or who are standing for the presidential elections. So the fixed answers are there. So that type of problems are called classification problems, and all of them are supervised learning examples. Another could be some regression examples where we talk about some mathematical output. Okay, some numerous output. For example, share market prediction, housing prices prediction. So share market prediction, you cannot predict that the answer would be either 8 of out of 102 or 103 or 104. It could be any mathematical continuous value. What will be the marks a student will be getting, or what is the market price of a particular house, or how long it will take to sell all these products, or how many products will be sold, how long it will take to this engine get repaired or before it gets repaired. So all these questions do have some mathematical fixed answers. So those sort of problems are called regression problems. And are regression problems supervised or unsupervised? They are supervised problems because we feed some known data through them. For example, in case of share market prediction, we need to feed some share market values of last 6 months. In housing prices prediction, we need to feed some data of how the housing prices changed in last 1 year or last 2 years. Talking about another example, let's say anomaly detection, detecting the anomaly. So whether it is supervised or unsupervised, like what exactly is anomaly detection is, for example, let us say that 20 people, a number of people are accessing a particular network, and an algorithm can find out whether a particular the accessing of a network or intrusion is good or bad. Like we don't feed data with good or bad. We just train the algorithm on a common set of intrusion, that this is the way of accessing network. If the algorithm identifies any new way of accessing network, the algorithm can detect that and trigger an alarm to you that there is a new way of accessing network. Or let us say that people from India are accessing particular website. So if there is an algorithm running up which is only analyzing that yes, people from this area are only accessing the website, and if it detects that a person or an IP address from any new location is accessing the website, it can detect the anomaly. Okay, and it can trigger an alarm that yes, this is something happening up. Now in this case, we cannot train the algorithm that other than India, from which of the locations people are going to access it, because the possible locations could be anything. We cannot provide some preset data, pre-labeled data to the algorithm. So anomaly detection is going to be an unsupervised learning, wherein we cannot provide some right answers what is that the algorithm has to predict. So that's an example of unsupervised learning. Recommendation, like if you go to Amazon, okay, there are a lot of recommendation system running on Amazon which recommends you books based on this 2 or 3 books you search, based on the ratings of those books, and based on the theme of those books, it recommends you some books that you can also read this book. So this recommendation system is also an unsupervised learning example. Some of the clustering examples could be telephone tower location within an area according to the density of users of a particular telecom service providing company. The algorithm can detect or provide you the location wherein you can fit your telecom tower for a telecom company. Recognizing some pattern topics, what kind of topics people are searching these days, or what kind of jobs people are searching these days. That's what Google AdWords or Google AdWords Key Analyzer does. Summarizing the news, that's what Google News does. Market segmentation, analyzing the market. For example, if I want to open a hospital in a particular city, let's say New Delhi, and which part of New Delhi there are existing hospitals, how much people spend there, and how much those hospitals charge, what kind of hospital services are provided by those hospitals. Analyzing all this data, I can predict that which area is the appropriate one for opening a new hospital. Clustering the genes, clustering some medical data, some plants data. So there are a lot of data that is unknown, some astronomical data. We cannot predict we cannot label a particular astronomical data. So for analyzing all those unlabeled bulk amount of data and finding out features out of them, we use clustering algorithms. And clustering algorithms are a type of unsupervised learning because we don't need any kind of labeling into that. So there are a lot of methodologies in machine learning. Some of them are supervised, some of them are unsupervised. Supervised could be linear regression, logistic regression, support vector machines, artificial neural networks. Unsupervised could be anomaly detection, nearest neighbor algorithms, principal component analysis. So these are sort of algorithms which are used for different cases, has different applications as well. How to choose which algorithm to use? So you can first choose based on the application that what kind of output you are looking for from a particular task. You can also evaluate different kind of models on your set of data, which one of them is giving you proper output. For example, let's say that you want to do some classification based work. Support vector machine in some cases works better. In some cases, k nearest neighbor, k means clustering. All this sort of applications works better. So depending case to case, some of the models may work better. You can also look at the relative success rate with different algorithms. You can also use rule of thumb that which algorithm takes minimum time, minimum memory requirement, and minimum processing, minimum complexity for a particular task. and the kinds of data as well. If you have media data, if you have numerical data, if you have bit sort of data, how many dimension of data, how many features of data set you're having. Based on that, you can choose the algorithm that you wish to use for a particular task. So we're going to look after a particular technique, that's the housing prices prediction, that's linear regression. So before that, am I clear with this sort of idea? The machine learning algorithm can be of two types, that's supervised learning and unsupervised learning. Any question of that? Okay, it seems no. So let's move on. So we're going to look after a particular easy technique to make you understand what exactly, how do machine learn exactly. So this technique will make you understand that how do machine learn and how do machine understand. So one of the example that I'm having is housing prices prediction. So let's say that I'm having some sort of data that for 1200 square feet house, the price is estimated price in Indian national rupees is 20 lakh. For 1800 we have 42 lakh. For 3200 we have 44 lakh. For 3800 we have 25 lakh. And for 200 square feet we have 62 lakh rupees. So let's say we plot this data. So we get some sort of plots like this. So we can say like the price of a particular house depends on the area of it. So we can bifurcate these two types of variable. The first area can be named as some independent variable on which the price depends. So price is depending here on some input data, or let's say some other type of data, that is area of a particular house. So X can be called as some independent variable and Y can be called as some dependent variable. And for a particular area, let us say that let's say you have to detect the housing price for 3500 square feet. So X, or the area, is the predictor variable or regressor, which helps you to, or which gives you the opportunity to find out the estimate or predict the output for a particular set of housing price. So a particular set of area for an house. So you can say the two variables, the first could be some independent and the second could be some dependent variable, wherein the price depends on the area of a particular house. This is only one feature. Now here area can be called as a feature for predicting the price. There could be another feature, the average spending of people in that area, the credit of the financial credit of every people living in that area, the educational qualification of the average educational qualification of every house in that area. So those all could be feature for predicting the price in that price of houses in a particular area. So you work on special set of features. In linear regression, we work on only one feature. So let's say that I plot this data on this graph, and if I want to design a basic algorithm, if I want to design a basic algorithm which can help me out to predict the price for houses in this area, so I can work on, let's say that so what I can do in basic simple ways, let's say that I'm having only two sets of data, so I can draw a straight line like this. That's not a very straight one though. Let's say that straight line is like this. So I'm drawing a straight line by using two sets of data, and using the straight line algorithm, this could be a very basic algorithm that we have learned in mathematics. How do you straight line is y equals to mx plus c is something basic equation of the straight line. M is slope and c is the intercept over here. So if you have only two sets of data, using two sets of data, you can draw a particular line which could be here, 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 anywhere. So this is the state of line using these two sets of data, and the better line could be this one. So this is some let's say some existing algorithm or some existing data that you're having. Let us say that as of now you have only two sets of data, this one and this one. If a new set of data, let us say that this one is coming up into your knowledge or into the knowledge of machine, which is predicting the house for this set of area as this much price. Now with the entry of this data set, we can say that this existing algorithm is not very correct one, and there can be more correct algorithm like not this one. This one could be more correct one. Now this existing algorithm passes through this data set, it also passes through this data set, but here it is having much error compared to this data set. Whereas this new algorithm, the red color algorithm, is having minimum error with minimum average error with all the data set. So this red color algorithm can be called as more accurate than that. And if we say, let's say that we feed the new data set as this one, then algorithm might change from here, wherein it has minimum error with respect to each and every of data set. So the main idea is we need to design an algorithm wherein it gets minimum error. For example, this is the current algorithm, so we have to train this algorithm, this hypothesis, y equals to mx plus c, this line, based on all the data set that we are having, so that it can have minimum error between this is the correct value and this is the value predicted by current algorithm. So if we can minimize this error between the correct value and the value predicted by current algorithm, if we can minimize this error with respect to each and every data set that is given to us, we can say we are training our algorithm. Okay, it could be simple, like let's say that y equals to mx plus c is the idea. Let's say that I'm having particular graph set of data as this one. All right, and I'm having two set of data, let's say this and this. I'm drawing a straight line through them. Now let's say only two set of data I'm having. It means I'm having two set of knowledge only. Now let's say if I add some more knowledge to this, some more data to this. Now the existing algorithm is not correct one, because there is error between the correct value. This is the input and this is the output for it. So this correct value so there is error between the correct value and the value predicted by the current algorithm. For this input, if the current algorithm, this is our current algorithm, is predicting any value, it would be somewhere here. So according to the value predicted by current algorithm, it will be here, whereas the correct value is here. It means there is error between the value predicted by current algorithm and the correct value. So machine has to minimize this error. So machine has to minimize the error by making its algorithm like this way. So this has minimum error or less error compared to the last algorithm. Okay, so this can be called as more accurate one. How do we do that? We can do that. We can change the straight line, the orientation of it, just by changing the equation. We know that y equals to mx plus c. So just by changing the slope and the intercept, we can make the algorithm have less error between the value predicted by the current algorithm and the correct value. So that's what we do in linear regression. We design a basic algorithm and we try to feed it more data, and every time we feed it more data, we try to minimize the error between the current algorithm and the correct value, the value predicted by the current algorithm and the current value. So let's say that this is the straight line. So the equation for straight line could be y equals to mx plus c, or we can also say if we replace m and c by w1 and w0, so it could be something y equals to w0 x plus w1. Okay, I just replaced m and c with w1, w0 and w1. So I can say, how can I minimize the error between the correct value? Okay, let's say what I have to do is I have to minimize the error between the correct value. So let's say the correct value is y and the value predicted by the current algorithm is y hat. Okay, so this is the value predicted by the current algorithm and the correct value is y. So what I have to do is I have to minimize the difference between y and y hat. Okay, so here this can be called as y and this can be called as y hat. This can be called as y and this can be called as y hat. So what I have to do is I have to minimize the error between y and y hat every time. If I can do so for every data set, then I can say that my algorithm is now trained much better than the few data set, and now it is ready to predict some data. So the main objective of linear regression algorithm is to minimize the error between the correct value and the value predicted by the current algorithm. And how it can be done? It can be done by changing these two values, w0 and w1. Let's see how. You see, for a particular value of w0 at 0 slope and w1 as 40, that's 40 intercept, the algorithm will have something like this line. For slope 0.8 and for intercept 0, it will have something like this, and for some other data it will have something like this. It means by changing the value of w0 and w1, we can change the algorithm and we can vary the error between the value predicted by the current algorithm and the correct value. That's we can vary the difference between y hat and y. And that's what the objective of a linear regression or a machine learning algorithm, that is to minimize the error. Okay, so the main objective is you can define the cost function as the square of the difference between y and y hat and the summation of it for every data set. And we use 1 by 2m, so that while differentiating this, 1 by 2 will be cancelled, because you see when you differentiate this with respect to y, this 2 will go and multiply and that will cancel it out. So there's a reason for taking that. So we have this can be defined as the cost function. We have to minimize the difference between y and y hat, and y equals to w0 x plus w1 could be the main equation. Parameters could be w0 and w1. Cost function could be this, and the goal is to minimize j, the cost function. So this is the basic idea of linear regression problem. I hope it would have been clear to you. We went a bit quick, but the basic idea is sufficient to understand. Objective could be, there are various objective of working with a linear regression problem. It could be to find out the relationship between two variables so that you can predict the data for new variable. Let's say that you have a relationship between the government or the government policy and the share market prices. So for a new government policy, the algorithm can predict what will be the share market price for a particular day or particular time, and you can you can design the relationship between multiple variables. Okay, the number of hours of study and the marks obtained, okay, housing prices and the area of house, the number of people living out there, or the amount of expenses people are doing, and there can be various variables wherein you can design the relationship between them, and you can help an algorithm to predict output for them. So prediction of new possible values is the another application of linear regression, and it is widely used in data analytics and data mining concepts work. So this is the whole idea of linear regression, and this was the complete idea of what we are going to do, like the basic concept of linear regression. Talking about in this course, what we are going to learn is in the 7-day course, like the topics which includes is fuzzy logic analysis, linear regression, artificial neural network, which is one of the very important topic of by which the deep learning concepts are backed up, and support vector machines as well, one of the very important topic while we technique for doing some character recognition, some digit recognition, principal component analysis where you want to do some data dimensionality reduction. Let us say that you have some 13 megapixel data. Let's say that you have some 1280 by 768 pixels of data. Now process that data, process each and every pixel is kind of cumbersome and complex task. To reduce that sort of features into small number of features, it could be, this one could be used. For example, let's say that predicting a particular, the performance of a particular employee in a company, the features could be his salary and his skills. Now you see the salary of an employee and the skills of an employee are much more related, or let's say the skills of a particular employee and the efficiency of a particular employee are much more related. So these two dimensions or two features could be reduced by combining altogether them into a single feature as the performance. So a lot of places we do data dimension reduction, feature reduction. So there we use principal component analysis, K-means clustering sort of data into that, genetic algorithm, one of the very promising technique of artificial intelligence. Out of this, the first and last are not a part of machine learning, and between that, the middle 5 are part of machine learning: linear regression, artificial neural network, support vector machines, principal component analysis, K-means clustering. But all these are different techniques for artificial intelligence. All of them come under artificial intelligence. But the fuzzy logic and genetic algorithm is not counted as the technique for machine learning, because there's the different techniques from learning. They don't learn, they simply predict. All right, another technique is something deep learning. Deep learning is very famous and very talkative, very buzzword these days, when we have efficient computers to perform a lot of layers of neural networks, when they can even detect the features and analyze them. So deep learning can be called as the technique of, we generally use machine learning technique to make a computer learn from the data. And deep learning is all about when a computer is learning how to learn. Okay, that technique is called deep learning, where a computer itself recognizes different features, and based on those features, computer gets trained automatically and then predicts some values. So it has been very buzz since Google acquired DeepMind and designed that algorithm of AlphaGo, which beat some go-kart champion in Go game. So it has a very buzzword, deep learning. So there are a couple of algorithms that I'm having that I can show you practically. We're going to use Python for programming, and a couple of applications I can show you a few. So let's say some sort of back propagation algorithm we want to do. So if I process this data, and this is a technique of artificial neural network, if you want to do some back propagation algorithm, so it tries to reduce the error every time you process it and show you the output of it. So the output of it could be something, well, let me check with that back propagation algorithm. Yeah, here is that. So you see the error is decreasing every time, and you see from it has been trained for 30,000 iterations, and every time the error is decreasing from It is started from 0.496 and it is decreasing up to 0.00005 like that. So this is how we try to reduce the error for an algorithm and we try to improve its performance. Okay, another better example could be, let's say this one, text classification or character recognition. So character recognition is generally done using support vector machine. So this is how we can recognize a character. So if let's say that the algorithm is having a particular set of character as some raw data, some handwritten values fed to it, and it tries to recognize what is the exact value for that set of character. Okay, so it takes a bit of time. My computer is kind of slow. So similar to that, some feature recognition, some digit recognition, a lot of stuff we are going to do, a lot of practicals we are going to do in each and every domain of machine learning throughout this course. And it's going to be completely around 80% of the course is going to be hand-shown session. So you see this character is recognized for the image, this one which looks like 5, and the computer is also predicting that this image is 5. Okay, you see the computer is predicting, the algorithm is predicting that this is 5, and this image is also 5. So this is an example of character recognition. Let's say sentiment analysis. I want to do some sentiment analysis on this. Let's say I have a couple of sentences. Manoj is good, smart, and funny. So this is kind of positive sentence. Okay, so let's do this analysis, sentiment analysis. So this is a part of natural language processing wherein we want to process some natural data, because whatever I speak, whatever articles we write on internet, you do some post on Facebook or tweet on Twitter, all those are into raw natural language, which is very, very ambiguous language. Because errors in computer language are completely different. Artificial language like C, C++, Java are completely different than natural languages that we use. Okay, so you see some of the examples of this is like Manoj is good, smart, and funny. So the negativity is 0, and neutral part of it is 0.167. The positive part is 0.833. The book was very good. The compound positivity is 0.497. When it is greater than 0, it is positive sentence. The compound value is greater than 0, it is positive. When it is less than 0, it is negative. So the value here varies between 0 to -1 to +1. You see, a really horrible book. So the compound value is -0.5849. So that means it is having negative sentiment. Okay, so either the sentence can have positive, negative. So the food in the hotel was not so good. So it is having compound as minus, whereas negativity is 0.275, neutral part is 0.725. There can be some ambiguity part as well. You see, like this one. The script was not fantastic, but the acting was decent, and the cinematography was excellent. So you see, the first part of the sentence is negative. The other part of sentence is positive. So it has both the component, negativity as 0.104, the positivity as 0.273, and the overall compound value is 0.07014. So this is what we do. How do we do sentiment analysis? Other than that, you look after text classification, whether a particular name is male or female. So let's say that I'm having my name as I'm having a name as John, and a particular name is Georgia, let's say. So a computer algorithm can recognize whether that name is male or female. So let me run this. So the first was John and the second was Georgia. So let's see whether the computer is able to predict whether a particular name is female or male. So there were a lot of examples we can do. So you see, first was male and second was female with the accuracy of 0.748. It can predict that. So there are a lot of examples that we can do with this, and so far we've seen a lot of all sort of data. This is one example of k-means clustering, wherein we are doing some clustering algorithm of colors. Okay, using OpenCV framework. Let's run this one as well. So we are just clustering the colors, similar colors altogether into the image. So you can see over here that the first image is the very much colorful image, and the second image, most of the colors are matched to the similar one. Okay, so it's kind of less color. The most of the colors are clustered together. You see this pink color part and this color part are clustered together because they look similar. This yellow as well. So here the K is equal to, I guess, 4 or 5 it is, white, black, blue, dark blue, and this brown and yellow are something colors. Those sort of work are computer vision, detecting faces, and doing some share market prediction, some cancer recognition, cancer detection, and using some sort of data sets that is available on University of California website, UCI website. We are going to do a lot of tasks into this, and you can look after the detailed content on the website of ours, that is techtrunk.in/artificial intelligence training, and here you can navigate, wherein you will be able to analyze the content of the training in every day, day-wise, day 1, day 2, day 3, this complete 48-hour course for the current continuous stay. If you are attending it into the online mode, this number of days will be again different, but the content will remain same. Okay, so these are the contents that you can navigate to this link, and you can look after the content. I'm just going to copy and paste this content in chat books so you can analyze it a bit later. So now it's the questions time. So if you have any questions now, you can ask to me. Yeah, Mr. Anand, you seem to have a question, so I'm going to unmute him. Meanwhile, you can also look after think of some questions if you have. Okay, Mr. Anand, I unmuted you. You can ask your question.
Okay, now I wanted to know, I mean, based on the complete demo, I understood that statistics is kind of very, very important in this, okay, and mathematics as well kind of plays algorithms and equations and everything. So this plays a lot of, crucial role. So, I mean, if somebody doesn't have any kind of exposure towards this thing, maybe, because it's a...
yeah, I understand.
So will there be any kind of basic brush up or anything that will be happening?
Yeah, there will be. See, like when we'll be starting with linear algebra, we'll be basically also doing some mathematical concepts on linear algebra as well. And while we'll be learning Python, at that point also we'll be learning basic idea of this. And we'll be also using some customized technique of doing all this stuff where you have ready-made functions, and we'll also be doing where you don't have ready-made function and you have to implement that mathematical equation in programmatic way. So both kind of stuff we are going to do. And like we'll also be providing some documents and some study material which can also help you out to practice this stuff and do it more work like on this with mathematical part of it. Okay.
And this is completely classroom or it's online as well?
Like online as well. It depends on the batches found on online part. Like classroom, we have continuous batches. The coming batch, as far as I remember, is on 10th of June coming up, or 20th of June. You can just connect to the marketing team and they can help you out that.
Okay.
And we have online batches as well. You can ask me questions if you have anyone. Or else we are ending up the training, so like webinar today, and thank you for watching this webinar and providing your valuable time for this, and I hope it would have been somewhat fruitful for you, and I hope you will find you will attend the coming future webinars as well on artificial intelligence and Internet of Things, and these are the two things that we are taking up very highly these days. So see you in the next webinar or in the next class. Thank you all of you. Bye-bye.